Hey everybody, we are in 11.4 of your Tennessee Revealed Geometry, and this is surface area. All right, so surface area is the area of all of the sides of a figure, kind of put all together. With that being said, you've got lateral area, which does not include the base. Your lateral faces, now that is like for a prism, all of the sides that make it three-dimensional. We're going to talk about altitude. We're also going to be talking about height and slant height. So those are not the same thing. And okay, we're doing composites as well. All right, that means more than one figure going on. So you have to find the surface area of one, surface area of the other, and add them together. All right, let's get into it. So you need to know the lateral area is going to be called L for a prism. It's the sum of the areas of all of the lateral faces. Again, what makes it three-dimensional, running from one base to the other base, if it has two bases. If it only has one, say like the pyramid is only going to have one base, you would find the area of all of the other sides and combine them together. Those are your lateral faces. All right. Let's see, altitude of a prism and cylinder is a segment that's perpendicular to it. And when we start talking about pyramids, I'm definitely going to be talking about actual height and then the slant height, which are not the same thing. Might have to do a little Pythagorean theorem in there as we go. We'll see. Okay, so your lateral faces, this is a triangular prism. And I know that because my base is a triangle on the top and my base is a triangle on the bottom. It has three lateral faces, this rectangle on the left, rectangle on the right, and then the rectangle on the back. Those are your lateral faces. Now, for a cylinder, you still have two bases, the circle on the top and the circle on the bottom, but your lateral is not a face at all because it's not a side. It's this three-dimensional cylinder that runs from the bottom base to the top base. All right, of course, you got that formula for that. All right. When you combine the lateral with the area of the bases, whether it's one base or two bases, you're going to get surface area. All right, so let's see here. And of course, they give us the formula for the cylinder as well. Okay, so yeah, let's just get into it because it's going to be a little bit easier probably to understand what L stands for, what B stands for as we get into it. But L is your surface area of your laterals, and then it's two B's because the cylinder has two bases, and B is the area of the base for the circle at the top and circle at the bottom. All right. Example number 1. So I am going to turn the page of your workbook. We started on page 655. Now we're going to turn to page 656. Example number 1, got to find the lateral area and surface area of this prism. All right, so let's see. First off, this is 1, 2, 3, 4, 5, 6, 7, 8. This is an octagon prism. So the base is an octagon at the top, and the base is an octagon at the bottom, so it has two bases. And all of these little rectangles right here are your lateral faces. And there are going to be 8 of them because it has 8 sides. So 8 lateral rectangles. All right, so first off, for the lateral, you find the perimeter of the base and you multiply it by the height of the prism. So just looking at this octagon right here, it has 6 equal sides. So you're going to add up 6, 8 times, or basically 8 times 6. And that's going to give you 48. So 8 times 6 is 48 because they're all 6 and there's 8 of them. Now again, H is the height of the prism. That is the length from one base to the other base. And that is 11. Again, not talking about the height of the octagon. We're talking about the height of the prism. And again, you're looking at the length from one base to the next. That's 11. 8 times 6 is 48. Times 11 is 528. Now to find surface area, you take this 528 and you add the area of the base twice because there's two of them, the octagon at the top, the octagon at the bottom. So we need to go back and find the area of this octagon. Now remember the formula is 1/2 PA, so it's 1/2 the perimeter times the apothem. Sorry, I said it wrong. The apothem. So we've learned this in a previous lesson, and first you're going to add up again 6, 8 times. So that's where that 48 comes from for the perimeter. But then you're going to have to find the central angle by taking 360 and dividing by 8 to get your central angle. And then you're going to divide that central angle by 2 to get the angle of the right triangle. All right, so here goes. 360 divided by 8. That's going to be 45. So again, that's your central angle. And if you are needing to look back at my previous lesson on finding the area of polygons, please do that because it goes into great detail how to do this. Then you're going to divide by 2 to get the angle of the right triangle that you draw. So take 45 divided by 2, and you get 22.5 for this right triangle. Okay, so this is where your trigonometry comes in because this is your theta. 3 comes from taking the side 6 and dividing it by 2 to get the side of the right triangle. And you are trying to find the apothem, which runs from the center of this octagon to the perpendicular side. Again, not to the vertex of the octagon because that would be the radius of the circle, not the same thing. All right, so we're going to do opposite 3 over the adjacent to find the apothem, and that's going to be a tangent problem. So you're going to put tangent of 22.5 because that's your theta. Opposite 3 goes on top, and the adjacent on the bottom. Now remember, you can't take 3 and divide by a in the calculator, so you're switching these two places because that's the trick. The opposite of dividing by a is to multiply by a. Then the opposite of multiplying by the tangent of 22.5 is divide by the tangent of 22.5. And again, if you're lost right here, then go back and look at those videos for trigonometry and look back at the video that I made for the area of a polygon. All right, take 3, divided by the tangent of 22.5. Again, make sure your calculator is in degrees. Otherwise, your answer is going to come out incorrect. And that's going to be your apothem right there. All right, so multiply 1/2 times 48 times 3 divided by the tangent of 22. And this is going to be the area of your octagon. 1/2 times 48 times 3 divided by the tangent of 22.5. And that's going to give you 173.82, yada, 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 yada. Now, this is the area of one base. One base. Remember, there are 2 bases to this prism. So you're going to take your 528. If you're wondering where that came from, again, that is your lateral. You're going to add 2 of the 173.8 because this 173.8 is the area of the base at the top and at the bottom. That's why there's 2 of them. And that's going to give you 875.6. So the surface area of this prism is 875.6 approximate square inches. All right, so that is all for example number 1. So let's move to the bottom of that same page to example number 2. I think cylinders are much easier than prisms because they are very, very cut and dry. We want to find the surface area and the lateral area. Of course, lateral area is going to come first to the nearest 10th. Okay, so this is a cylinder. Now, students and teachers, they're brand new. Make sure your students know that when the line goes all the way through, this is a diameter, and it makes it a trick question. You've got to take that 10 and divide by 2 to get your radius. And the reason I say that is because the formula for lateral area is 2 times pi times the radius times the height of the cylinder. So we need to have the radius, not the diameter. So 10 divided by 2 is 5. That 5 replaces the r. The 9 is the height. And again, it's the length from one base to the other base. So 2 times pi times 5 times 9. Now remember, on typically big tests, they keep answers in terms of pi. So you would multiply 2 times 5 times 9. So I teach my students to keep it as a pi. So it'll be 90 pi. Now, if you are someone who prefers a decimal, just multiply 90 times pi in your calculator, and that gives you approximately 282.7 square inches. Now, this is your lateral. To this, you add 2 area bases, or the 2 base areas. Well, this cylinder has 2 circles for its base. Now, the formula for the area of a circle is pi r squared, and there's 2 of them. And remember, when the line is all the way through, that's a diameter. Divide by 2 to get your radius, which is 5. So pi r squared for the area of the circle. There's 2 of them. Replace that r with a 5 and grab a calculator. You're going to be looking at 439.8. So the surface area of the cylinder, 439.8 approximate square inches. Like I said, I think cylinders are much, much easier. All right, so a couple of more examples. If your teacher wants you guys to do that. Moving on to page 659. All right, talking about surface area of pyramids and cones. All right, a regular pyramid is when the base has all equal sides. If the base is a rectangle like this, and it's regular, it's actually a square or possibly a rhombus, so that all 4 sides are going to be equal to each other. All right, let's see. Altitude. Okay, let's talk about that. First off, altitude of a pyramid or cone is a segment perpendicular to the base. And it has its vertex at one endpoint and the point of the plane of the base at its other endpoint. Okay, for lateral area, you got 1/2 PL, which again is the perimeter of the base, but this L is your slant height, not actual height. So when I start teaching this, I usually talk about the pyramid, the Bass Pro, downtown Memphis. It's a rectangular base, and it has an elevator that goes to the observation deck. Now, that elevator is actual height because it runs from the observation deck, which is at the top, all the way straight down to the middle of the actual floor. So that is your actual height. And then I ask my students, hey, how many of you guys have actually been up in the observation deck? How many of you have ridden the elevator? That's your actual height. So I kind of make it relevant. Then I talk about slant height. And I say, okay, so imagine taking the elevator straight up to the observation deck, getting on an intertube, and sliding down the side. That is slant height because you're coming down the side of the pyramid, not down the elevator of the pyramid. So that's your slant height. And that's the part that is in the lateral area because you're talking about these triangles that make up the 4 sides of this pyramid. Okay, so with that being said, it's 1/2 the perimeter of the base times your slant height. All right, for a cone, we again use L for the lateral area. This is your true height. And of course, this is a right cone, but you can also have an oblique cone. So I don't know if you're going to have any like that, but actual height is straight up and down. This is slant height for a cone. And this is the hypotenuse of this right triangle, by the way. All right, so it's pi times your radius times your slant. All right, surface area. So you take your lateral and you add the area of the base, and because there's only one B. Same thing for the cone. There's only one base, one circle. That's why there's only one b. So only one pi r squared. All right. So it looks like we've gone through all the formulas on page 657 of your consumable workbook. I'm going to go to the next page for example number 4. And they want us to find the lateral area and surface area of this rectangular. No, it's not. It's a regular triangular pyramid. All right, so all three sides of this triangle are 6 because it says it's regular. All right, we got to find the perimeter. So we're going to add 6, 6, and 6. Or you can just say, hey, it's 6 times 3, and that's 18. So your 18 goes right there for the perimeter of your base. Now we need the slant of the pyramid, and that is the one that's running from the vertex of the top perpendicular to its triangular side, and that's going to be 8. So we have 1/2 times 18 times 8, and that is 72 square feet. But remember, this is your lateral area. We need to add on the area of this base in order to find the surface area. And there's only one base. There's only one b. Okay, so we have to find the area of this triangle. All right, so to make it easier, what I did is I pulled up my GeoGebra and I drew a triangle that has 6 equal sides. 1, 2, 3, 4, 5, 6. And I made it regular. So this is the same length all the way around. So 6 on all 3. All right. The formula for the area of a triangle is 1/2 base times height. So I need to find the height here so that I have 1/2 base times height. Well, remember, this is an equilateral triangle. That means all 3 sides are 6. And when I take this AB side and split it, I get 3 and 3 for a right triangle. So if you looked here and saw a Pythagorean theorem, this is why. We need to find this height using the 3 for one leg, the height for the other leg, and the 6 for the hypotenuse. So that's why it's a Pythagorean theorem. So a squared plus b squared equals c squared. It's going to be a squared plus 3 squared equals 6 squared. You subtract 3 to the other side. Put that in your calculator. You're going to get 27, and the opposite of squaring is the square root. So the height of the base triangle, talking about this triangle base, that is the square root of 27. All right, so 1/2 6 times the square root of 27 will give us the area of this triangular base. And there's only one base. All right, so it's 15.6. And we need to add our lateral with our, okay, I'm getting ahead of myself. So the area of the base is about 15.6. There's only one of them. So you add the 72, which is your lateral, to the area of the base, which is about 15.6. Combine them together, you get about 87.6 approximate square feet. Okay, moving on to example number 5. Lateral area and surface area of a cone. Again, I love cones and cylinders. They are pretty easy. Now, you might have to, if they give you actual height, do the Pythagorean theorem to get the slant. So do consider making sure you're paying attention. But the lateral area for a cone is pi times your radius times your slant height. Our radius is given. It is not the line all the way through. So the 0.8 is my radius. Nothing to divide here. So put in 0.8 for the radius. And they give me the slant. They give me the 2 things that I need. But if they had given me the actual height, I would have to do the Pythagorean theorem to get my slant, which is 2.2. All right, so grab a calculator. And you're going to put in pi times 0.8 times 2.2. And you're going to approximately 5.5 squared millimeters. Now remember, this is the lateral, just the cone part. We now have to find the area of the base, which is a circle. And, okay, looks like they did that for me. It's pi times 0.8 squared. There's only one of them because there's only one circular base. Remember, the cone has two. That's why it's 2 times pi r squared. All right, so it looks like I am ready to grab a calculator and put in 5.5 plus pi times 0.8 to the power of 2, because it's pi r squared. And we get basically 7.5, actually 7.51, but the 1 doesn't make the 5 move, so 7.5 squared millimeters. All right. All right, there we go. There is example number 5. All right, that's the bottom of page 658, so I'm moving to the next page, page 659. All right, example number 6. All right, we need to find, looks like just the surface area of this pyramid and cone, but I don't see a cone there, so maybe there's one coming up. All right, here we go, example number 6. All right, specialty watermelons are carefully cultivated in containers so that the fruits form different geometric shapes. Kurt wants to build molds to grow watermelons shaped like triangular pyramids. All right, so we did a problem like this just a minute ago. It looks like the base is 2x all the way around, 2x, 2x, and 2x. So I'll tell you what, my visual people, I'm going to help you guys out. And we're going to make this 2x all the way around. 2x. 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 Oh, that's a horrible looking 2x. All the way around. That means if I split this, this is an x. I do not know the height, so I have to do the Pythagorean theorem. A squared plus b squared equals c squared. So x squared plus b squared. Again, looking for the height here. Equals the hypotenuse c squared, and in our case is 2x squared. Now you're noticing that I'm using parentheses, and that's because I have to square the 2 as well as the x. Okay, so let's take care of that first. So x squared minus b squared equals 2x squared. All right, so you might sit in here and be looking a little confused by that. And I can totally understand that. So let me break this down using an equation editor. It might be easier. All right, so we got x squared plus b squared equals, and in parentheses, 2x to the power of 2. Okay, now I'm going to leave x squared plus b squared alone and just worry about this right here for just a second. So x squared plus b squared equals, okay, so 2 to the second power is 4. X to the second power is x squared. Now, if you've forgotten your algebra skills, a power to a power, you multiply the powers. This is understood 1 power times 2 is 2. Now, 2 squared is just 2 times 2 is 4. All right, the opposite of adding x squared is to subtract to the other side. So I'm going to be left with b squared. Subtract x squared to the other side, so 4x squared minus x squared is 3x squared. The opposite of squaring is to square root. So we're going to square root, leaving the b by itself, and we're going to square root the 3x squared. Now I'm going to do this all together so you guys can see my steps, because you're going to get confused if I skip steps. Okay. Now, there's no such thing as the square root of 3. 3 times 1 is 3. There's no pairs. There's no square root of 3. But if you remember your algebra skills, the square root of x squared, remember the square root and the square canceled out each other over here, so they will cancel out over here. So you're going to be left with b equals x on the outside of the root, but 3 has to stay on the inside. So again, the square root and this squared cancel out to be just a b. So it will work the same on this side. The square root of x squared canceled, leaving just the x on the outside of the radical, but there's no such thing as a square root of 3. So this is your height of the triangular base. What you just found is this height of the triangular base. It is x square root of 3. Now this is important because the base is a triangle and the formula for the area is 1/2 base times height. So we have the base is 2x, which goes in for the b, and the height is the x squared root of 3. That goes in for the h. Okay, so back to it. Watermelon can be modeled by using a regular triangle, which I just talked about. The perimeter is 2x plus 2x plus 2x, or 2x times 3, and that's 6x. All right, the slant height is the 4x minus 4. Oh, okay, my bad. 4x minus 4. Right, so that's your slant height. All right. Now, it looks like we need to calculate the area of the triangular base is 1/2 base times height. The height of the triangular base is x squared root of 3, which we just did and just proved. All right, and the length is 2x. Just talked about that. All right, substitute these values to find the formula. All right, so we got area of a triangle is 1/2 2x times the x squared root of 3. Oh, this is a typo. The x should be on the outside. That x should be on the outside of the radical. The 3 is on the inside of the radical. So watch out for this typo, you guys. This is a oops. That is definitely an oops. Now, they fix it right here because x times x is x squared. And then you see they put it on the outside. And the 1/2 and the 2 cancel each other out, leaving just the square root of 3. But yeah, watch out for that typo right there. That's an oopsie on whoever's part this is, whoever wrote this particular lesson. All right, so we got 1/2 the perimeter, and we need to get that from the 6x. The slant height is the 4x minus 4. That's your slant right there. And then we need to add on the area of the base, which is the square root of 3x squared. Now, you're probably wondering where they got this. I would be too. So I'll tell you what, they skipped a bunch of steps. All right, let me pull this back up so you guys can see what they've done, because they have skipped a lot of steps. All right, let's get to a new one. All right, so we've got 1/2 okay, and then times the perimeter. Remember, that was 2x plus 2x plus 2x, that's 6x. And times the slant height. So that was my 4x minus 4. Oops. To this, we add the area of the base. This, remember, is the square root of 3x squared. I like to put my x squared out front so you realize that it's not actually underneath the radical, because people do get confused by that. All right. Okay, so this is plugging in. Okay, now let's break this down. 1/2 times 6x is 3x. All right, so I'm just going to kind of bring that down so you can kind of see what I'm doing here. All right. Oh, hang on a second. I just realized that parenthesis is in the wrong place. That parenthesis should have been right there, and that parenthesis should not have been there at all. Looks like it's not being nice to me. All right, so let's back up this train. I don't want my people to get confused. Okay, let's start all over again. I got 1/2 times 6x, and then the 4x minus 4. Tell you what, I'll take care of this first. That way people don't get confused. And then I'll add on the base. All right, so 1/2 of 6x is 3x. Now I'm going to distribute here. 3x times 4x is 12x squared. Oops. There we go. All right, 3x times a negative 4 is a negative 12x. Okay. Everybody okay so far? I hope. Okay. This is just the 1/2 PA. Just that 1/2, I said PA, 1/2 PL. All right, to this, I'm going to add on the area of the base. This is your x squared square root of 3. Okay, so I just added on the b. Now I'm going to show you how to go from this to this. So they skip some steps, and you're probably sitting there going, yo, what did they do? All right, so this 12x squared and the x squared square root of 3 are like terms because they're both x squareds. They're both x squareds. So what they did is they combined those. They combined them. All right, now they took out the GCF when they did it. So the 12x squared and the x squared square root of 3 are like terms. They are being added, and the GCF is an x squared. So they said, okay, well, they've got 12 plus the square root of 3, and x squared is the greatest common factor. So they put the GCF in the back when teachers usually teach it up front. All right, then we have the minus 12x. It does not have a like term to combine with. So if you're wondering how they went from here to here, yeah, that's how they did it. So these are like terms because they're both in x squared. The GCF is the x squared, so 12 plus square root of 3. If you're a new teacher, you're going to have students that try to put 12 square root of 3. That's multiplying. This is addition. 12 plus the square root of 3 cannot be combined. Not 12 square root of 3 anyway. That's multiplying. All right, so x squared and then minus 12x. So if you're wondering where they got that, that is it. So that confuses my students quite a bit. All right, you guys, and then they ask us, okay, well, what if x is 6? So at this point, we're just going to do a little plugging and chugging. So take that x, replace it with 6. Take this x, replace it with 6. Grab a calculator. So we got, in parentheses, 12 plus the square root of 3, close parentheses, times 6 squared, and then minus 12 times 6. Should be looking at approximately 422. Now it's a 0.35, so the 5 makes a 3, round to a 4. So I got 422.4. 422.4 square inches. All right. Woo-woo. Bottom of page 659, we got a sphere. I like spheres. Spheres are easy as long as you have the radius. If they have the line all the way through, remember that's your diameter, divide by 2 to get the radius. All right, they give me the radius. So the formula for the surface area of a sphere is 4 pi r squared. So I love it because it's easy. You replace the r with the 7.1. So we got 4 times pi times 7.1 squared, which is about 633.5 squared millimeters. All right, let's try one on your own. All right, so here's the trick. The line goes all the way through. That is your diameter of the circle. Divide by 2 to get your radius. 22 divided by 2 is an 11. So we're going to multiply 4 times pi times 11 squared. 4 times pi times 11 squared. All right. For my visual people, 4 times pi times 11 squared. All right, grab that in your calculator. 4 times pi times 11 squared. Looks like 484 pi. If you're going to leave it in terms of pi, 484 pi. If you're going to put it as a decimal, 1,520 point. Now it's a 5-3. So the 3 does not change the 5. And that is square feet. All right, guys, looks like I am... Oh, no, I am not done. Let's see, moving on. All right, okay. Surface area of sphere again, but they give me circumference. Interesting, okay. And they want me to find the surface area. All right, so let's see. So circumference is 3 pi x squared, and they want me to find the surface area. Okay, no problem. So listen, your surface area is 2 pi r, right? Because it's 2 times pi times the radius. But they are going to replace the c with the 3 pi x squared instead of equal to the formula 2 pi r. The opposite of multiplying by 2 pi is to divide by 2 pi. All right, so we've got 3 divided by 2. Does not simplify. Now, pi divided by pi cancels out. The x squared is just there. This is your radius. You're going to come down here to the formula 4 pi r squared and put all of this into your r. Don't forget to square it. All right. Visual people. All right. We got 4 pi. Now, 3 over 2 squared. 3 over 2 squared is 3 squared over 2 squared. So 3 squared is 9. 2 squared is 4. 3 squared is 9. 2 squared is 4. Now, when you have a power to a power, remember you multiply those. 2 times 2 is 4. Okay, now we're going to multiply 4 times 9 over 4. Well, actually, the 4's cancel each other out, just leaving 9 pi x to the 4th. 9 pi x to the 4th. 9. Where's my pi symbol? I think I looked over it. 9 pi. 9 pi. Come on, where are you? There you are. 9 pi. X to the power of 4. All right. All right, we got a composite here in my last example. Okay, so what they did is they chose to break this down into a net, and this is a really good idea, and here's the reason why. What I have found in the past years when talking about surface area of composite figures is that students forget that there's no top to this rectangular prism. So you got a mailbox. You've got a rectangular prism on the bottom, which has no top, because it's replaced with half of a cylinder. And so volume, it doesn't make a difference if there's no top or not, because you're putting stuff inside the prism. But this is surface area. And because this prism has a cut off top and it replaced it with a curved half cylinder, there is no extra rectangle. So you've got the base, which is this one. That's the base that it's sitting on. You've got this right rectangle here. You've got the left side rectangle here. You've got the front square here. And you got the back square here. All right, so let's talk about that. All right, so you got the length of 12. Oh, it's not going to let me put it in. It's not going to let me put it in. So this is to be a 12. Okay, it's in your book. So this is a 12, 7, 7. and this is a 7. Okay, for the circle, remember the diameter is 7 for the circle. So this is a 7. Again, 12 for the length of the height of the cylinder, or half cylinder in this case. 7 here. And they take the radius and cut it in half, which is 3.5, because 7 divided by 2 is 3.5 in a pi. They don't leave me a lot of room. I love it. So remember, because this is surface area, there's no top of this prism. It has been replaced with the curve of the half cylinder. So that's why there's not an extra rectangle right here. All right, you're going to multiply 3, because there's 3 of them, 7 times 12. 3 rectangles. That's why there's 3. 7 times 12, 7 times 12, 7 times 12. There are 2 squares. This square, 7 times 7, and this square, 7 times 7, 2 of them. All right, over to this half of a cylinder. 12 times 3.5, because it's 12 times the radius. Half of 7 is 3.5 pi, and there's only one of them. And then put these 2 half circles together, you get a full circle, which is 3.5 your radius squared times pi. Do all of that in your calculator, and you can see it's 520.4 square inches. All right, so if you're a brand new teacher, watch the students on this one. They'll try to put in an extra rectangle right here, because what they'll try to do is split it into a prism and a half cylinder. And when they do, they're going to get the extra rectangle that's not actually there. So their number is going to come out bigger, and they'll have to subtract off the extra rectangle that they're going to put in. Yes, and that means that more than likely they may miss it if they try to do it that way. All right, guys, that is it for me. Your practice problems are up for you, and good luck to you. Ask me questions. Ask your teacher questions. All right, you guys, have a good one.